Welcome to Fun Maths. Today we'll be evaluating limits and looking at the limits of exponential functions. The first question says evaluate the limit as x approaches infinity of this divided by this. Both of them are quadratic equations. Now, how do we evaluate this limit? If I was to put in infinity for each of them, we'll be having infinity divided by infinity. And I want to solve it in a different way, with a different approach. So this is what I'll do. Let's say we have 2x squared plus 3x minus 5, and then we have 3x squared plus 4x plus 7. What if we divide the numerator by x squared and also divide the denominator by x squared throughout? So we'll be having 2x squared divided by x squared plus 3x divided by x squared minus 5 divided by x squared. Everything is also divided by 3x squared, also divided by x squared, plus 4x divided by x squared, plus 7 divided by x squared. The purpose of this is so that I will have at least one of them without a variable, without x or x squared, and that particular one will be left alone. This is what I want to do. If we divide this by x squared, this will cancel, right? And then x cancels one of these. This nothing cancels, so we leave that. This will also cancel. X will remove one of these, and we have that. So what we have next is 2 plus 3 over x minus 5 over x squared divided by 3 plus 4 over x plus 7 over x squared. Now, come back to the limit. The limit as x approaches infinity of 2x squared plus 3x minus 5 divided by 3x squared plus 4x plus 7 is equals to the limit as x approaches infinity of 2 plus 3 over x minus 5 over x squared divided by 3 plus 4 over x plus 7 over x squared. Now, this and this are the same. The only thing is that when you are dividing by x and x is tending to infinity, which is a positive infinity, it means that the value of x keeps increasing. If you divide 3 by 2, you keep dividing it by a bigger number, it will tend to 0. This also will tend to 0 as the denominator increases. When you are dividing by the same numerator, it tends to 0. So we have 3 over x, 5 over x squared, 4 over x and 7 over x squared, 4 over x and 7 over x squared, they tend to 0 as x tends to infinity. I hope you understand. So it means that this is going to be 0 based on our limit. This is going to be 0, this is going to be 0, and 0. So what do we have left? 2 plus 0 plus minus 0 is 2. 3 plus 0 plus 0 is 3. So this is equal to, let me rewrite that, limit as x approaches infinity of this 2 plus 3 over x minus 5 over x squared divided by 3 plus 4 over x plus 7 over x squared would be equal to 2 over 3. Since everything is 0, 0, 2 over 3. That's the answer for the first one. The second one, which is B, says, now the reason why I brought two questions is because there are different approaches. We have the limit as x approaches 0, exponential x minus 1 divided by x. Well, we can't divide both of them by, let's say, x. It wouldn't make sense, right? I don't want to do that. So what I'm going to do is, what if we just use 0 immediately? We'll be having exponential 0 minus 1 over 0, right? Exponential 0 is 1, that will be 1 minus 1 over 0, which is 0 over 0. That's what we call indeterminate. We can't find the value for that. So that's not possible. This is not possible. So what do? We use a rule called L'Hopital's rule. L'Hopital's rule. You can pronounce it whatever way you like. Something like this. The rule states that you are going to differentiate the numerator and the denominator separately, then you will use the limit. Okay, so if we differentiate this differentiation d dx of exponential x minus 1, we differentiate the numerator, we'll be having differentiate exponential x is still going to be exponential x. When you differentiate 1, is going to be 0. So this is exponential x. While for the denominator, differentiating x will give you just 1. Now we'll bring that back, but we'll not apply the limit. Let me clean this side. Okay, so back to this, we have the limit as x approaches 0, exponential x minus 1 over x will be the same thing as the limit as x approaches 0. Exponential x, after differentiation, is exponential x. And then we differentiated x, we had 1. So now if you apply this 0, we'll be having exponential 0 over 1. Exponential 0 is 1, so this is 1 divided by 1, which is 1. That's the answer. Okay, please do want to like this video, share this video, and subscribe to this YouTube channel. If you have any question, drop it in the comment section and I'll try to answer. Until we meet again, bye bye.